All right, hey. I guess this is to help Nicole and Liana. All right, so I'm hoping you guys are watching this. I did some of the questions, or parts of A, B, and C and D to help you guys out. So let's start. So the question says you got to find the pH at all the following points. Uh, you have originally 25 mils of the acid and 0.3 moles per liter of the acid. And your acid is HF. And then you're titrating it with a strong base, and the concentration of the base is 0.3, and the Ka value for HF is 6.6 times 10 to the negative 4. The initial pH is really simple. I'm sure all you guys know. Basically, initial pH is just when you have the equation HF goes to H plus and F minus, the initial concentration was 0.30, 0 for these, xxx, 0.3 minus x, x and x. Ka is equal to x squared over 0.3 minus x. Use your 100 rule. You find it's greater than 100, so then just solve for x, and then x is equal to 0.014. And then that's hydrogen concentration, and then pH is just negative log of that, so pH is 1.85, which if you check the answer is pretty close. Now for B, the question is asking, after adding 12.5 mils, after adding 10 mils. So after adding 10 mils of 0.3 molar NaOH. So now we calculate the moles. The moles of OH, basically just this guy, because we don't have to worry about the Na, is just 0.01 liters, because that's 10 mils, times its concentration, which is 0.003 moles. Now the moles of HF is just its concentration times its volume, and that's just 7.5 times 10 to the negative 3, or 0.0075. Here you just take the subtraction. Now you're taking the moles of the acid, subtracting with the moles of the base, because acid and base cancel out. So then 7.5 to the negative 3 minus 3 to the negative 3, and you get 4.5 to the negative 3. Now what is this? This is your leftover acid. So what was your acid? Your acid was HF. So now you have your equation again, the same equilibrium ice table as the first part A. HF goes to F minus goes to H plus. Except now we don't know the initial concentration of this new equilibrium. Well, it's just moles over volume, and we know the moles of acid left over was 4.5, and we know the volume is 25 mils plus the 10 mils added, and that's 0.035. And if you do that division, you should get 0.12857. So that's the concentration of HF. Now we need the concentration of F minus. Concentration of F minus is the moles of the base over here. So it's 3 times 10 to the negative 3 divided by same total volume, because volume doesn't change, and you get that number. So now we go over here, and we have basically the same ice table. HF goes to F minus H plus. Initial is now these two numbers that I have here and here. Oh, I moved it a little bit. And okay, so then you have the same minus x, 0.128 minus x, 0.857 plus x, and x. Ka is equal to this times that over this number. 100 rule, you'll notice it's greater than 100, so then it just becomes 6.6 times 10 to the negative 4 is equal to 0.0857 over 0.128 times x on the top. If you do that calculation, you should get x is equal to 9.9 times 10 to the negative 4, which is the concentration of H plus, and pH is just negative log, which is 3.00. Alright, so that's part A and B. Where's the thing? What the hell do I, oh, that's weird.